Well, I may have finished my effort at why I attempted to write articles on Wikipedia recently, even though I was being kind of underhanded about it, because I didn't come out right away and say, well, I'm going to talk about Joseph Newman, because I knew I couldn't. So I beat around the bush, and one said, one person criticized me for my opaque writing style. It's true, I wasn't being straightforward with them. Um, and eventually, when I realized that I wasn't getting anywhere, I wasn't going to, no matter how hard I tried, then I came out and admitted what the whole point was for me to get involved. Even though I knew I didn't belong, I got involved anyway, and it was good that I did because I received all their criticisms, their critical judgment. I took it personal, unfortunately, to some degree. I was feisty, argumentative, but all that's past, and I hope they forgive me as much as I do them because it's really pointless to think or worry about arguing or disputing. I don't know. I take it personal because I don't like the fact that people like Joseph Newman get bad-mouthed, especially when they're dead. I don't like it when that happens when they're dead and can't defend themselves. But be that as it may, when I know that the truth is differently in my heart, it's another thing to be able to argue with somebody, and there's no point to argue if you can give evidence. It may not be authoritative, but as far as I'm concerned, a simulation is as good as it gets because I don't have to build it, and I can show the principle behind it. Because what I figured out was I had to stop trying to produce exactly the same numeric output values and instead just get the ballpark, the general idea. So when Dr. Hastings tested Joseph Newman's motor and he found that there was a slight amount of negative amperage arising within the battery pack, that's one clue. And so I'm happy to report I've managed to succeed at doing a few things, namely the battery pack here represented by V1 has negative current, and we have to correct it. And I tested this just to make sure, because I read on the internet that LT-Spice has a habit of giving you the opposite polarity of current reading on your voltage source than what it actually is. And it's always consistently opposite. It should be coming out positive, and they say, no, it's negative, or vice versa, whatever. So I tested it. I built me a little test circuit of one voltage battery, not this kind, but I used a cell battery. They have a schematic symbol for a battery, a two-terminal battery, one that you don't ground, not round like this. It looks like a battery, and a resistor and the wire connecting it to make a loop. And I put up the readouts, and sure enough, the resistor was positive, but the amperage was negative. The amperage on the resistor was positive, but the amperage on the battery was negative. So I knew right away, well, it's true. LT-Spice has this weird oddity to it. And you'll think, oh, negative current, wow, over unity. No, you have to fight for it. Well, you have to design for it. And this is what I've managed to do. And what's weird about this, see, all the voltage disappeared coming from the battery. It went to 0 volts. So what's going on here? What I realized was the power gain. You know what runs this motor? It ain't the coil. Joseph Newman keeps saying, oh, the coil this, the coil that, massive amount of copper. We'll get to that in a minute. It's important, but it's not the cause. There are such things as causative problems, and then there are effective or effectual problems that result from the first cause. There's a root cause. And then there are all these secondary effects that are also problems and complicates the matter and makes it difficult and confusing to find the first cause, the primary cause that started the mess. Well, in this case, there's a primary cause that powers this thing, and it ain't the coil. It's the magnetism of the permanent magnet set in rotation. That's a massive magnet. And Paul Babcock, at the Science, Energy, and Technology Conference in Hayden, Idaho, kept saying, magnets are a source of energy. And don't let any physicist or electrical engineer tell you differently. They are a source of energy, and we just have to figure out how to use it. Well, Joseph Newman figured out how to use it. And it's a 2 or 3 step process, depending on how involved you want to get. It's a minimum of 2. The third step is optional. So the first step is you got to have yourself a big, massive, permanent magnet that you set in rotation using your good old arm or whatever, a starter motor, but something to get it moving. Now, the next problem is that you have to, you have to provide a methodology by which you can absorb, receive that magnetic flux in such an efficient manner that it's able to run the device off of the magnetism of that spinning magnet alone and nothing else. So what does he do? He creates a massive coil, so massive that it cannot run on current. It can only run on voltage. And he supplies it that way, with voltage from a battery pack. Not a whole lot of current. Little 9-volt batteries all strung in series, a lot of them. And those batteries' sole purpose is not to provide any power for the device, but to provide power for the circuit. See, there are 2 ways of looking at a circuit that has to do with power amplification. And one is, how much energy does it take to run the circuit? And the other is, how much energy does it end up producing? And they're not the same, because they're sourced differently. And by this methodology of simulation, I find out, in short order, because Constant 314 was complaining, well, you've got a waveform that's very chaotic, and it shows there's a strain on the simulator. Well, I said there's a strain on any over unity device. Wrong. Only if you don't know what you're doing. So I was trying to power the circuit based on the battery pack alone, and that was creating a strain on the voltage source that was supplying voltage to the spinning magnet in the simulator. And that was my mistake. So I took the position, well, why don't I try to beef up the voltage on this voltage source that's supplying voltage-oriented power to the spinning permanent magnet? And lo and behold, that was the problem, the oversight. That was the oversight all along. I had to supply more voltage. And we know from either Joseph Newman or Dr. Hastings, all these people, that the coil ends up with more voltage than what it gets from the battery pack. And previously, I was trying to build up voltage in that coil from the battery pack alone, but that put a strain on the voltage that was coming from the magnet. I didn't realize a magnet can give voltage, but an electromagnet is no different than a permanent magnet, except that you can analyze what the permanent magnet has to deliver to the circuit in order for the circuit to have those characteristics that we've come to know, that Joseph Newman's motor works. In other words, the current in the battery pack has to be negative. It has to show that there's a slight amount of amperage going into the batteries. The net flow of amperage, obviously something comes out, right? Or else, it wouldn't be powering the circuit if it didn't. But more has to go in than what comes out, so that the net effect is that we recharge the battery pack with a slight gain. And in this simulation, I have it's a sine wave that seems to be undulating around a median of 18.6 microamps, give or take 8. So it wavers between 19.2 negative microamps is the low, and the high would be 17.8 microamps. It doesn't show the number for some reason, but that's what I'm guessing it should be there, because this is not a logarithmic scale, it's a balanced scale. And that's another thing. Well, yeah, not all these scales are balanced. Anyway, let's see. So I got the battery pack to go negative in amps, which is what I'm supposed to do. Unfortunately, I got the volts of the battery pack to go to 0, which is a little excessive. It's not supposed to do that, I don't think. But it had to go to 0 because the amount of power that I was pumping into the coil, the big massive copper coil, from the rotating permanent magnet. So the first thing is that the permanent magnet has to be massive and set in rotation. It has to move. But the second thing is you want to pick up all that magnetism in the form of voltage, not in the form of amps, because this is not a conventional motor. And to do that, you have to set up your pickup coil, first of all, to be massive, second of all, to be voltage-oriented, which is the same thing in a sense. But voltage-oriented not only because it's massive, but because it's being fed predominantly voltage from the battery pack, also because it's a massive coil, so it's not going to allow a whole lot of amperage to flow through it by comparison to the voltage, will be very large. So we have this, basically this coil is a field magnet. It's a field magnet as a receiver to receive the rotating magnetic field of the rotating permanent magnet. And so in order for this coil to receive it, it has to be charged up, and it's not going to get it from the magnet, so it gets it from the battery pack. So the battery pack is running the circuit. That's all it does. It does not provide any power. All the power comes from the rotating permanent magnet, and the coil is there to pick it up. And it has to be configured right, it has to be large, and it has to be fed mostly voltage predominating in order to capture the magnetic field and accumulate a charge of voltage in it, because that's all it needs to do. All it needs to do is acquire a lot of volts. So when we analyze this thing, we look at the rotating magnet, and it's delivering, or it's putting out, a sine wave of 800 volts, positive and negative. And then it's putting out amps, 40 kiloamps, positive and negative. And the total wattage, though, is 2 megawatts positive and 18 megawatts negative of that rotating magnet. That's a tremendous amount of power. So you can see right away, in terms of the simulation, what over unity, We're losing most of that power coming from the rotating magnet, and it's just going off into space and not being used, and we get to use a small amount of it transferred to the coil, that the coil is able to hold on to, accumulate or acquire, let's put it that way. It acquires it, and it holds on to a very fraction of what the permanent magnet puts out. Of course, we don't have to pay for the permanent magnet. All we have to do is set it in motion with our arm or whatever, a starter motor. And when they make the magnet, they have to charge it in a huge electrostatic field, and they have to put it in a magnetic field at the same time, and then they have to raise its temperatures so it can reorient all the little iron atoms to have the same magnetic orientation. So that takes a lot of energy. And then it has to, it doesn't have to do anything. Magnets, will hold on to their magnetic charge for some time, provided they're not heated back up again. They're kept, cool, room temperature, not the temperature they were heated at when they were being charged. Actually, not an electrostatic field, it's an electromagnetic field. Snafu there. So the magnet is providing all the power, and the battery pack merely runs the circuit, and the coil is designed along with the battery pack to be very efficient at picking up the energy from the magnet in the form of voltage alone, which is fairly easy to do. And it's funny that Joseph Newman didn't know to put the spinning magnet on the inside of the coil at first. He had it off to one side. And somebody said, why don't you put it inside? It'll be more efficient. And lo and behold, it was. Now, the third thing that's optional but does help a lot, tremendously, is the capacitor. Because you get a lot of arcing. And the arcing is detrimental. It loses energy. In other words, the coil fails to do its job of acquiring all of that magnetic, acquiring some of that magnetic field and holding on to it if there's no capacitor in here in parallel with the coil to help assist the coil do its job. And so once I figured out to lower the henries, lower the inductance of this permanent magnet and increase its voltage, Then I was free to increase the capacitance on this capacitor and get very good results. Otherwise, I couldn't do it unless I first increased the voltage of the permanent magnet and lowered its inductance. So it's not functioning as an electromagnet, right? Or else I wouldn't be reducing its henries. It's functioning as an electrostatic magnet. See, this is a funny thing. We never think of a magnet as an electrostatic device, but it is, because we supply it volts, and the volts end up on the coil. And that's all we want to show up on the coil is predominantly volts. So what shows up on the coil in this example? A sine wave that has a peak of 192 volts and a low of 180. But the amps is merely 20 amps positive and negative. Very little amps by contrast to the volts. So we're accumulating predominantly volts in this example. It is just an example to loosely orient us into a proper way of looking at Joseph Newman's motor. And then there's no mystery. You know, where does the energy come from? How does it acquire it? You know, it's no mystery anymore. The simulator solved the problem only because I went to Wikipedia and they complained, very astute individuals who knew what they were talking about. I'm speaking of Constant 314. And by giving me that clue, I just went back and I reworked the problem, and now I have no complaints. I have nothing to argue about. It's obvious. There's no magic. It's no over unity if you take all the sources of energy into account. But you know, if you wanted to sell it, your selling point would be, well, at least you'll be recharging the batteries and you won't have to keep buying them. And the magnet's not going to wear out anytime soon if you take care of it and don't abuse it by allowing it, you know, by subjecting it to heat. Now the coil may heat up, but the permanent magnet doesn't produce any heat of its own. Now whether or not it acquires heat by its interaction with the coil, I don't know. And that could age it. That could shorten its lifespan. I don't know in real life. The simulation doesn't tell me that. So I feel kind of cool that I figured it out finally, but only because I took the guy's criticism seriously enough to figure, okay, I got to rework the problem. I got to keep looking at ways to, you know, what ways did I not try yet in monkeying around with the values of all these components? Well, I didn't try raising the voltage on the voltage source for the permanent magnet simulation. Now, I knew that lowering the henries helps raise the voltage, so I did that. That was the first thing I did. But then I had to try raising the voltage as well. And the interesting thing about making all these changes is now I don't have to wait a tremendous amount of time for this thing to do all the computations necessary to be able to draw out all these tracings. It's very fast. It's instantaneous. And it's instantaneous because all these lines are thin. They're not squiggly. They're not thick. You know, in other words, they're not chaotic, as in the words of Constant 314. So it's a blessing to finally figure this out and make it run smoothly and quickly. You know, that's a really cool thing. So I posted this at the talk page, you know, the flip side, you know, the talk side of decoupling capacitor, I think it's called, on Wikipedia. You can do bypass filter and it'll redirect, or bypass capacitor might redirect as well, I don't know, but bypass filter I think redirects. And then you go to the talk side of that page, which is, you know, behind the page. And of course you can say whatever you like. You know, you don't have to be worried about somebody deleting your talk because it doesn't conform to their rules. You know, fringe, you know, Constant 314 said, well, this is all fringe. And so that's when I started arguing. But all I had to do was solve the problem, go back to work, and then there's nothing to argue about. There's no fringe to it. You know, what's fringe about this? There's absolutely nothing fringe about this. This is totally legitimate because it's not over unity. If we take all the energy sources into account, there's a lot of loss, tremendous amount of loss. So by ignoring the permanent magnet and focusing on the coil, Joseph Newman managed to kid himself into thinking that it was an over-unity device, in which now I can see it's not. And I think all of our over-unity devices made by inventors, if they came out of the closet and stopped being secretive about their device, and if we were open-minded enough to take them seriously enough to analyze, simulate it, analyze it, think about it, discuss it, we'd realize none of them are over unity. And this was the position taken by Peter Lindemann in one of his lectures at the Science, Energy, and Technology Conference, that if you take all the energy sources into account, there's no such thing as over unity. We say, okay, well, it gets it from its environment. Well, in this case, it gets it from the magnet. So there's no hokey pokey here, unless we're ignorant, and then it appears to be hokey pokey, and then we can argue about whether or not it's fringe, pseudoscience, fraud, or for real. But it's really out of ignorance that we wouldn't know. And it's out of authoritative personages who want to make snap judgments because they've never taken the trouble to work the problem over and over and over again, always on the presumption, maybe it can be done. It's okay, so how do I set about doing it? And the simulator environment makes it so easy because you can make changes very quickly. It doesn't cost you any money, and you can't electrocute yourself. All you can do is make mistakes and quickly correct them, provided you are not short of new ideas. Okay, now what do I try? So that's what it is. It's done. I find, there's no mystery to the Newman motor anymore. So I think I should email this to Patrick Kelly. His website, Free Energy, I think it's called .com, and then it's freeenergy.co.uk. He has a mirror. Because this totally legitimizes Joseph Newman's motor, once and for all, as far as I'm concerned. By taking it out of the realm of mystery, by taking it out of the realm of hocus pocus, and makes it very thematically legitimate. There's nothing illegitimate about this. Okay, I think I've said enough. I'm going to shut up now. It shows you how enthusiastic I am. Now, you can get the circuit from various places if you don't want to just take this image and try to do it by hand, There is an easier way. So, let's see if I can find the... I was going to read about this. It tells you all about the Newman motor, so I should actually email this guy. Yeah, right. It's a shortcut. What's the shortcut? is.gd/Newman Chap 6. That's one. Newman Chap, NEWMANCHAP, numeral 6. That's one place. Another place you can get it from is is.gd/pray numeral 4 Newman. Pray for Newman. Pray numeral 4, though. Those two places will have a link to the ASC file so that you don't have to construct it from scratch. If you don't want to, who would want to? I wouldn't want to. Well, I did, but I wouldn't want to if I was you, right? I'd want all that done for me, or else why am I going to bother? Why should I trust you, Vinny? You could be making this up. You could just draw all these things and then draw these things and, okay, whatever. Why would I want to go to all that trouble? I'm not that good an artist. Anyway, hey, we don't know. Who do we know? We don't know you from... Okay, enough already. Oops, wrong button. Gotta push the right button here.